Hello everyone, Professor Lohit here. Today we want to see the lecture number 19 on grade composition on horizontal curves. So at the horizontal curves, due to the turning angle alpha of the vehicles where the rear wheel drive, the curve resistance developed is equal to T1 minus cos alpha. Okay, that is because when you negotiate in the curve, what happens? The steering, only the front wheel has the motion, you can turn it around, that is where the steering is attached, but rear wheels are fixed. So whenever you turn the steerings, the wheels also turn along with that will create the resistance, the traction whatever is going to produce when it is at a straight. When you turn the steering, due to it makes the alpha with the what straight traction, that gives you T cos alpha, that is nothing but the reduction of the traction from T. The T will be always greater than the T cos alpha. This is comes into the picture when you have the curve resistance. Okay. So when there is a horizontal curves, in addition to the gradient, there will be increased resistance to the traction due to the both the horizontal curve resistance, this is the horizontal curve resistance, and the gradient too. In other words, what we call the total resistance will be like grade resistance will be there and the curve resistance. It is necessary that in such cases the total resistance to the grade, the curve should not normally exceed the resistance due to the maximum value of the whatever the grade specified. So for the design purpose, whatever the maximum value may be taken as a ruling gradient. In some special cases, what we take limiting gradient or even exceptional gradient for the terrain. So whenever the sharp curves is to be introduced on a road which has already the maximum permissible gradient, then the gradient should decrease to compensate for the loss of traction due to the curve. And this whatever the reduction in the gradient for the horizontal curve is called grade compensation. For example, if this is the vehicle, this this is the alignment which have the traction with along with the up gradient. So obviously there is some gradient right now. Okay, the gradient is going on. Again in between the curve is introduced here. Then what happens? The vehicle obviously will slow down here. Again due to the curve resistance also it will get the more, the speed decreases. Again you are having the up gradient. How the vehicle can climb now? Obviously traction will reduce. For that reason at the particular curve you are going to reduce some what grade there. That what we call is a grade compensation. That is given by the formula, empirical formula. Grade compensation is equal to 30 plus r divided by r is nothing but the radius of curve in a meter, and this is expressed in a percentage. So the maximum value of the grade compensation is given by the limited to the formula 75 divided by the r. Clear? According to the IRC, the grade compensation is not necessary for the gradient which are flatter than the 4%. Clear? Then the compensated gradient is given by ruling gradient minus grade compensation. Let us see one simple problem on what? Grade compensation. While aligning a hill road with a ruling gradient of 6%, a horizontal curve of radius 60 meter is encountered. Find the grade compensation and compensation grade at the curve. So as per the given data, the ruling gradient is equal to 6% and the radius of the horizontal curve is 60 meter. So therefore the grade compensation is equal to 30 plus r divided by r, that is nothing but 30 plus 60 divided by 60, r is nothing but radius. So you get around 1.5%. Now let's just check for the maximum limiting of a grade compensation. So the maximum limit of grade compensation is nothing but is given by 75 divided by r. So 75 divided by 60, that gives you around 1.25%. So it has to be less than that, but it is more. So therefore, what the grade composition is supposed to be provided? 1.25. As I stated here, the maximum value of grade composition is limited by this. If it is below this, then we are going to adopt this. If it is shouldn't be more than 75 r. But as seen to this from our prom, it is 1.5 and 1.25. This is the maximum what we can provide, not this. Clear? So therefore, provide a grade compensation is equal to 1.25%. So lastly, the compensated gradient is equal to ruling gradient minus grade compensation. That is nothing but ruling gradient is 6% and this grade compensation is 1.25. So it is going to be 4.75%. This is the compensated gradient. I will stop here. Thank you for your patience hearing.